Hi everyone, welcome to today's session. Today we are going to talk about Explainable X5GON. So X5GON is the Horizon 2020 project I am affiliated with, and today what I'm going to explain is how we incorporate some of explainable artificial intelligence when we design and develop AI technologies within this research project. So as a starter, I'm just first going to walk through the overview. So I'm going to start with giving a bit of background context, starting with what the X5GON project is and what type of AI research we do. And then I'm going to speak about several components of the project that has elements of explainable AI that are associated with it, and then finally conclude with the future directions that we want to go into in relation to this research, and also the open questions that we need to answer in the process. So X5GON project is to do with open educational resources. And what are open educational resources? Open educational resources are educational resources that are being created by teachers all over the world and then published and released to the general public with no cost access. What that means is this type of educational resources has very limited licensing constraints or licensing restrictions, and they are motivated to contribute to the collection of educational resources that are available in the world, and for other teachers or educators to use this content to build on top of them. So if you think about open educational resources, and when you take the internet, there are loads of open educational resources that are being circulated around in the internet. And if you can see from this map, so this map shows these bubbles with numbers. These numbers are not educational resources themselves. These bubbles show numbers of educational resource repositories or collections of OER that is scattered around the world. So what the X5GON project tries to do is to use artificial intelligence to first discover these open educational resources, and then try to match them to learners who are in need of these educational resources at the right time. So how are we going to do that? We are trying to do that by using artificial intelligence to understand the educational resource, and then to understand the quality of this educational resource, and to understand learners so that we can find the right educational material that can be matched to the learner at the right time. So in the process of doing that, we create several AI technologies. When we do that, we want to keep explainability and human friendliness in mind when we design these technologies. So this project is a Horizon 2020 project funded by the European Union. And this project involves several European partners, including partners from Slovenia, Germany, France, and Spain. And you can see here a few faces. So these are the members from UCL who are involved with this project, mainly to do with building artificial intelligence and also the human-computer interaction components of this learning system. And today I'm going to discuss most of the work that is being done by these members who are in this slide. So what are we trying to build in terms of AI within the X5GON project that I'm going to focus today is we are trying to build a system that would help learners to engage with educational materials. So in terms of doing that, when you look at the literature, you can find that there are several components or several factors that affect educational, people engaging with educational materials. So one of them is the quality of the educational resource. Then when you learn about things, you need to have some element of novelty What that means is when you read educational resource or consume an educational resource, you're motivated to learn something new, so you expect novelty. And then educational journeys involve trajectories. You can't just keep learning new things in random. There are certain sequences of knowledge that make sense to learn, and then when we learn, the personal interests also play a huge factor in how motivated you are to learn. So based on these findings, we have formulated a Bayesian network which sort of represents the different factors that affect a person's engagement with the educational resource. And what we are trying to do in one part of the project is to build an artificial intelligence system, which is a recommendation system that will take into account these factors and then try to match how compatible a learner is to an educational resource. So most of the AI in X5GON that I'm going to discuss today are revolving around this concept. And as the theme of this meeting is explainable AI, today I'm going to explain the explainable AI aspects of the work we do. And in terms of that, I'm going to sort of rescope my domain, where rather than just saying explainable, I'm going to talk about the human-friendly artificial intelligence that we are building, which involves three different aspects, as argued by Balog, Redelsky, and Arkayan in relation to recommendation systems. So one of them is transparency, which is to do with how transparent an artificial intelligence system is in terms of presenting what the system does as it is to the user. Then there's explainability, which is kind of similar to transparency, but more to do with how does one explain what the artificial intelligence system does to the user. And then there's also the factor which is scrutability. What that means is, can the user look at these explanations and the transparent aspects of this system and scrutinize the system? Or, one example is, can the user say what the AI is doing is wrong, for example? So one could feel that transparency and explainability are kind of the same thing, but as these researchers argue, they are, although they are similar, they can be two different things. For example, how you would understand a mathematical concept as a human may not necessarily be how you would explain that phenomenon to another person. So similarly, what the AI system does in the face value may not be how you explain what it does to the user. So this is where transparency and explainability could be different in certain scenarios. And in today's talk, what I'm going to do is to take a few different parts that I just outlined in the overview, and then discuss how we try to incorporate these three aspects of these three aspects in our AI systems. So first, what I'm going to do is to discuss on the content quality. What that means is, in this project, we are building machine learning systems that can identify the quality of educational materials. And in support of doing that, what we've done is we've gone through various literature from different domains, and we've identified certain features that are indicative of quality in information. And what we've done is we've built machine learning models that help us to predict how good the quality is in an educational material. And why this is important, like the choice of features is important, is one of the core components that make it easy for us to make explainable systems that are humanly intuitive is by choosing features that are more human intuitive and that are more familiar for a human to understand. So that way it's easier for us to align the meaning of the machine learning model to a symbol that humans can understand, which leads us to my next slide, where in this work what we show is we use certain model agnostic explainability approaches, namely the shapely values, to identify the feature influence of these machine learning models. And why this is interesting is because in the previous step we decided to use features that are humanly intuitive. We can very easily understand what the model is doing by looking at these SHAP values or the SHAP plot. So here one of the interesting things you can understand is what this model says is if a educational material is fairly long, which means when it has a high word count, which means the pink dots on the top column, the engagement tend to be towards negative. So what that means is if you are to watch a very long lecture, the engagement of the learners drop drastically. And similarly, from the second column, you could see that the more fresh the information in educational material is, the more engagement it gets. So one of the interesting things that we see by taking more humanly intuitive features when we design machine learning models is that we could find feature influence explanations that align more intuitively with our human beliefs, and it's easier for us to understand what's going on. So this is some of the earlier work we've done in this project, and now I'm going to go into the more personalized aspect of machine learning that we are building in the project, which is building the personalized educational recommendation system. So here what we've done so far is to build this model, this learner model that that tries to infer the knowledge that a person has based on the type of videos that they watch, and also model the amount of novelty a person is receptive to, and based on that predict if we present a particular lecture to a particular learner, is the person going to engage with this lecture or otherwise. So when we were designing this TrueLearn algorithm, we were thinking about several features that has to be incorporated in this educational recommendation system. And one of the features, as you can see, is incorporating transparency into this model. So having transparency is quite popular and sort of a requirement in educational use cases because there are ethical implications to these models. For example, if we are recommending educational materials to a user, based on the recommendations we make, we are literally shaping that person's future. Therefore, the accountability, the degree of transparency that is required is high. And if you look at educational data mining research community, you could see that most of the models that are popular amongst the community also incorporate transparency at the core of the design. So due to these reasons, we also decided, we thought that transparency should be a core value that has to be incorporated in this model, and as a side effect, it builds trust between the user and the learner, user and the model, and also in an educational use case, it sparks metacognition processes. For example, if the model is transparent and if the learner can know what this artificial intelligence is doing, in a learning perspective, it could trigger scenarios like reflection or self-awareness. We will see in the later slides how this is incorporated. And in terms of this model, the first thing that we had to think about is what type of representations we should have in this model. So here, one of the main requirements of educational resource recommendation system is to have a content representation. What does that mean? We need to have a representation that represents the educational resource. So the most popular method to do this in educational data mining community is to extract what is called knowledge components. So what are knowledge components? Knowledge components are atomic units of knowledge that can be learned and mastered. So what usually happens is you have a bunch of experts who sit and look at an educational resource and say, okay, this particular video deals with the knowledge component of multiplying two numbers or area of a square. So those are kind of atomic concepts that a person can learn. The problem with this method, as you can see, is when you have handcrafted domain expert labeling, it's very expensive, and you can only do it for particular domains. For example, you get a bunch of physics experts, you can do it for physics, and you have a knowledge component set for physics. To overcome this problem, people have proposed automatic methods, mainly to do with learning deep neural representations, and also using unsupervised methods such as topic detection or clustering. The problem with these methods is, because of the unsupervised nature of these methods, they lose interpretability to some extent. You probably know a lot about how there are interpretability challenges with deep representations, and on top of that, if you have unsupervised learning methods, there are problems like tuning hyperparameters is very complex. Due to this, there are challenges of these methods. So what we've identified is there could be ways where you can meet in the middle. So one of those methods is entity linking, which is a method that would take a string representation or a text representation of educational material and associate this text representation to Wikipedia concepts. Here, the opportunity is that you can do this at scale, because Wikipedia is a vast knowledge base, and entity linking is a machine learning approach that has had good advances in the last few years. And as we are associating these materials to Wikipedia concepts, we still stay in a humanly intuitive topic scope or a topic domain. At the same time, some of the things that we are losing is contrary to getting handcrafted knowledge components by domain experts. The Wikipedia concepts may not necessarily align with the pedagogical structure that is proposed for a particular subject, for example, for physics. So these are some of the drawbacks of this, but in general, this seems like a good approach to retain scalability while losing some accuracy in terms of the pedagogical robustness. So because of this method, what we can do is we can automatically annotate these educational resources, and this is the method that we used in the TrueLearn algorithm. So TrueLearn algorithm is many things. In terms of the explainability, one of the features associated with transparency is that TrueLearn algorithm retains the humanly intuitive learner representation. What does that mean? When a learner interacts with educational materials in the system, the TrueLearn recommendation algorithm, because it keeps the content representations in the form of Wikipedia topics, it also over time builds a learner representation of the knowledge the learner already has in the space of Wikipedia topics. What that means is, at any given time, you can have a look at this learner representation, and most of this representation makes sense to you because it is represented in a form that is understandable to humans, which is Wikipedia topics. So now we are going to look at a bit more on this TrueLearn algorithm. And here one of the problems that we are trying to solve is that to introduce a recommendation system that keeps a easy to interpret learner model that integrate critical factors of learning, such as the learner's knowledge, the amount of novelty that the content presents, and also the learner's interest. So currently there are two popular approaches that is being used in educational data mining community. One is item response theory, the other is knowledge tracing. One of the interesting common grounds between these two methods is they are both Bayesian methods and they both retain interpretability to some extent. So if you're familiar with a bit of machine learning, the item response theory is a method that is used to learn the difficulty of the questions and the skill of the learner at the same time. But at the end of the day, you have this parameter that you learn which represents the skill of a learner. Knowledge tracing, on the contrary, learns a Bernoulli variable which is a Boolean value, which is the probability if the person has mastered a particular knowledge component or otherwise. So what we are doing in TrueLearn model is to extend the item response theory, which will allow us to retain a humanly intuitive representation while improving the performance of the model, because now we are incorporating novelty into this model. And as you can see here, using Bayesian networks is a great way to build models if you are interested in keeping transparency and explainability to a higher degree, because these networks, what Bayesian networks do is to allow you to build models that align with human beliefs. So now I'm going to emphasize a bit more on the explainable AI side of TrueLearn algorithm. So as I explained earlier, the TrueLearn algorithm builds a learner representation which is in the Wikipedia topic space. What that means is all the different parameters that you learn in this model are Wikipedia topics or Wikipedia pages. So you can see that from the figure on the right. So there are three knowledge components for which the values have been learned, and these are like, one of these is statistics page, the other one is base rule, and then the other one is dolphins. So apparently this person knows a lot about dolphins. And then TrueLearn algorithm, the TrueLearn algorithms are capable of maintaining a humanly intuitive representation, which is also explained in the figure on the right. So what the TrueLearn algorithm does is to learn a Gaussian parameter, or in other words, a normal distribution for the skill estimate of each Wikipedia topic that they encounter by consuming educational resources. So here you can see that there are three normal distributions that have been learned by the TrueLearn model. One of them, which is the blue one, is for statistics, the orange one is for base rule, and the green one is for dolphin. So the mean of this normal distribution, which is where the peak is in the x value in the x-axis, that is the estimate of the skill that the TrueLearn algorithm has for individual topics. And then there is the variance of the Gaussian distribution, which represents how certain the algorithm is about this estimate. So in another sense, about this person, the algorithm believes that they know most about dolphins. When you look at the three topics that are shown in this figure, and the algorithm is extremely certain that this person knows this much about dolphins, which is shown by the thin normal distribution, which has very little variance. And how does the variance decrease in this TrueLearn model? When you have more and more successful events of people consuming educational resources about dolphins, the mean of the skill dolphin goes towards positive side, and the variance of the Gaussian distribution decreases. And the interesting opportunity in this representation is by looking at this representation and with very little understanding of statistics, you could derive a few claims about the learner, about the AI's understanding of this learner's knowledge. So this is how, using the TrueLearn algorithm, we try to build explainable, transparent learner representations. And here I have also mentioned that these representations are scrutable. So scrutability is for the user to intervene and try to change the AI's understanding of the world. So here what you know is, if you are the learner whose representation is presented to you like in this figure, if you know that you know more statistics than Dolphin, this representation allows you to scrutinize this model and correct it. So this is another opportunity that this learner representation provides by having this type of model. So from the TrueLearn model, now we are moving more towards the front end or the user facing side of things. So here now I'm going to briefly discuss about this intelligent user interface component that we have created, which is called a content flow bar. And here what I have is a video demo.
We'd like to demonstrate a new interface that enables users to engage with recommended content in a way that is fast, interactive, and informative. Our example application here is a personal learning system that recommends video lectures. As you can see, certain fragments are highlighted to indicate high relevance. As a user, I can hover over these fragments to get a sense of the context and jump directly to the corresponding moment in the video.
Probability of the data. This is simply Bayes' rule.
Notice that the speaker said Bayes' rule rather than theorem, but it was picked up correctly by the topic extraction algorithm we use to automatically create these annotations based on Wikipedia items, which is a way to make it general purpose, domain agnostic. It works across languages and it doesn't require expert labeling. These annotations can help the user quickly preview what's next or what came before. The user can write a note, or they can use one of the shortcuts. All of these interactions provide explicit and implicit feedback to the system about how useful a recommendation was for the learner in a particular situation. And of course, that's important information that the system can then use to improve over time. The ranking of the recommendations is based on the knowledge components and their predicted relevance to the user. Bright yellow in this case means high relevance, and the more yellow, the higher the ranking. Notice when hovering over the cards, the user gets a quick summary of the main topics. We call this a ranked tag cloud. This feature is useful in two ways. Firstly, it gives the user a quick idea of the knowledge domain, so genetics, cognitive science, etc. And secondly, in cases where this information is missing from the title and metadata, like in this case, the tag cloud can fill in the gap, so it adds a consistent layer of information to a diverse dataset. It's a rather subtle intervention, but it can make the whole user experience more cohesive, especially in cases where you're dealing with different formats, videos and ebooks and podcasts, and so the tag cloud and the fragments bar can provide a unifying element and a unifying way of interacting with different types of data. In this example, we're only using videos, but you can easily imagine an audio player or PDF viewer, for example, to be embedded in the same way, also with the fragments bar. So the point is really to invite users to focus in on the fragment, see what works for them, and then come back and look at other things without losing context. So the idea of using the pop-up came out of testing with real users in real situations, where it turned out that because it's now so easy to focus in on something specific, you also want to be able to come back out and look at other things in the same scope without changing to a different page and losing the context. So using a pop-up in this case really adds to the fluidity of the whole user experience. And in general, we've had very positive feedback from users on this interface, and we're looking forward to demoing it.
Yeah, so in this particular example, in this user interface, we have focused on a few things that is important in terms of transparency, explainability, and scrutability. So one of the things is, while enabling the learners to navigate through content more efficiently, we are also providing transparency through this system, because we are presenting the content representations to the user as they are consumed by the artificial intelligence. So earlier I explained to you in the TrueLearn algorithm, what we are doing is we are taking these educational materials and associating them to the knowledge components, which are the Wikipedia topics. And here through this interface, what we are doing is we are showing to the user exactly what knowledge components or / Wikipedia topics that we are associating each fragment of the educational resource to. And if the user is unfamiliar with some of these topics, the interface goes an extra step to inform the learner about these topics by giving them a small extract from the Wikipedia page that will allow them to quickly familiarize with that concept. Also, there is an option to search for materials about these concepts if they want to get a deeper understanding of the topic. And then, as explained in the video, the highlighted parts in the content flow bar presents the relevance of certain fragments to the search keyword. And this also plays as a rationalization or an explanation of why a certain content is chosen for a particular search keyword. And I'm going to do a quick demo in a few minutes, and there I can demonstrate to you some of these explanations and rationalizations in detail. On top of that, if you see the right side subfigure, which is on the right side, you can see that there is a private notes section which will allow the person to provides an opportunity for the user to scrutinize the recommendation system by providing feedback that can be actively used to shape the AI to correct itself, especially if a particular recommended material is too hard or too difficult for a learner. The learner can explicitly scrutinize the system by using these UI components. And again, another added advantage which is not provided right now in the inbuilt system is because the learner is presented with the Wikipedia topics that are being extracted by the entity linking algorithm. The user can also look at these materials and say, for example, in the left-hand subfigure, there's robo, machine learning, reinforcement learning, speech recognition, and classical conditioning. For example, by looking at that part of the video, the user can understand that maybe reinforcement learning is not being mentioned in that part of the video. So the user has the opportunity to scrutinize the entity linking algorithm and correct it by saying this is a misclassification. And that provides additional data for the artificial intelligence system to get better. Then finally, before I go to the demo, we also, what we've done is we've taken all these AI components and put it into one intelligent learning platform, which is available at x5learn.org. And here we have also provided this switch, which is called Unveil the AI. By turning on this switch, what it will do is it will highlight the different parts of the platform that uses different components of artificial intelligence, and then through those submenus we provide links to explanations and interactive demonstrations on how these individual artificial intelligence components work. By doing this, the learner can familiarize more with the AI components that are shaping their learning experience. So here I'm going to now go for a quick demo. So here what I've done is I've searched for machine learning and I've been given these results. And here what you can see is if I go to this content flow bar, I can see that there are three fragments in this material which have been highlighted in yellow, which indicates that these fragments have machine learning concept in it. And when you go to the entity linking topics, you can see that these three components have machine learning in these fragments. So this way we provide the rationalization or the explanation of why this material has been provided as a result for the search. And then, as I was saying, you can look at the description and also look for materials relating to this topics. And here another additional thing I could show you is, we have these different representations that summarize the topics that are in the different topics, in different resources. And when you take machine learning, for example, you can click on this machine learning topic and see the different parts of the video where machine learning occurs, and you can see the exact extract from the transcript of the video that led to the AI believing that there is a mention of the topic machine learning in this part of the video. So you can sort of go deep into how the AI decides on these different decisions, and allows you to have a higher degree of transparency and explainability through these justifications or rationalizations. And here I was talking about this unveil the AI switch, where when you turn it on, what happens is you get these highlighted parts where you can click on one and it will give you the AI components that are being used in this section of the system. And when you click on that, it will link you to a separate page where you see an explanation about the AI technology, and you can also demonstrate, or you can try this AI technology out by itself. So Wikification, for example, provides you a demonstration where you can try Wikification in action for any text that you prefer. So this way we are incorporating different functions in our system to improve transparency, explainability, and scrutability of the system. So what are the future directions for us in X5GON and X5 Learn in terms of explainability? We want to enrich how the recommendation decisions are made by incorporating learning trajectories and learner interests into the system. And all of these things, because they are built on top of Wikipedia topic space, we can make sensible rationalizations that are more intuitive to humans. Then we want to think about how we want to justify recommendations in terms of narratives. So narratives could be the type of visualizations that we showed earlier, or it could be a story that is presented in natural language format. So this is one of the interesting directions where we can go in terms of improving the transparency and explainability of the AI technologies. Then we also want to identify the right way of presenting the learner models to the learner. So in the figure that we looked at earlier, we had 3 topics where it was dolphins, Bayes rule, and statistics. But in a real life scenario, these learner representations have thousands of topics when they go through hundreds of videos. Then how do we scope the amount of data that we represent or we present to the learner at one given time? How do we choose what subset of the learner representation we have to present at first, and what type of navigation should we allow them to have within that learner representation to cultivate metacognition processes? So these are some of the interesting things that we want to look at, and ultimately all of these things will lead to having the human more centered in the AI system that we are building. And when achieving this, there are several open questions that we want to answer. One of these things is when we go for models such as Bayesian networks or more simplified models that are rich in explainability or human intuitiveness, we tend to sacrifice predictive performance sometimes. So how do we balance this is one of the major questions that we want to explore, and that is still unanswered. Then how do we go from the representation we have to the presentation, which is, the physical form that the learner would see this information coming from the AI. Then the final part is, now we provided opportunity for the users to scrutinize the system, but how do we effectively use that feedback to shape the AI in a more correct or an improved form? So these are some of the open questions that we are still wanting to answer, and I hope in the coming months and years we would be able to go further in these topics and answer these questions, hopefully. And that's what I've been planning to show you guys about our project today.